Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 10, Section 5, Trigonometry and Area. So this section is really two parts. One deals with an area formula that we can use for triangles, and the other part deals with how to find sides and angles of a triangle that are not right. Okay, so we'll start out with the area formula of a triangle. You can use this formula anytime you know two sides and the included angle. So can be used when you know two sides and the included angle. Okay. So this formula says that the area of a triangle is 1/2 the product of the lengths of the two sides and the sine of the angle that is included. Okay. So it really doesn't matter what side is A, what side is B, and what side is C. The important part is that suppose I know sides C and B, then it would have to be angle A that I'd have to know in order to use this. Or if I knew sides A and B, it would have to be angle C that I would know in order to use this formula. So what I want to do is I want to show you where the formula comes from. It's pretty quick. So I'm going to draw a triangle, any triangle. And just so it matches the formula, I'm going to say that we're given A, and we're also given, here, wait, let me label the other side. So this will be B, and this will be C. So I'm going to put what we know in red. So we can always name the sides the same as the angle that's opposite it. We just use lowercase letters for the sides and uppercase letters for the angle. So I can call this little side A, and I can call this little side B, and I'll call this little side C. Okay, so I put in red, suppose they actually gave you the angle and they gave you the two sides. So I'm going to assume like I know those, and I want to write a formula that's just in terms of angle A, side C, and side B. So what I'm going to do is I'm going to draw the altitude. And I'll call this altitude x. So the area of any triangle is 1/2 the base times the height. And if I substitute, the base is just little side B, and the height is x. So what I'm going to do is I'm going to come over here and I'm going to solve for x in terms of the other variables. And if I'm given A and C as the hypotenuse, x is a side that's opposite, so I can use sine. And the sine of A is going to be x over C. And if I solve that for x, x is just C times the sine of A. And if I take this and I plug it in here for x, what I end up getting is the area is 1/2 B, which I'm going to know, C, which I know, and then the sine of A. And that's the formula they have right there. So it's a nice formula to use anytime that you have an angle and you have two sides. Now here's a pretty quick example. So for this one, the area of this, they give me two sides, they give me the angle between. It doesn't have to be a right triangle. This works for any triangle. So the area is going to be 1/2 BC sine of A. So it's 1/2 412, 386, and then the sine of 71. And if I put that in my calculator, I get that my area is about 75,184 if I round up to the nearest foot squared. Okay. Now, I might not be given the two sides and the angle that's between them, so the next thing we're going to learn is some ways that I can find sides of a triangle if I'm given other parts of the triangle. So this formula only works if I'm given two sides and the included angle. The next part of this section has some formulas that you can use if you're not given necessarily two sides and the angle between them. Suppose you're given all three sides. You can use the next formulas to find an angle. And these formulas, the law of sines and the law of cosines, work for any triangles. Don't have to be necessarily right. So the first one is called the law of sines. This is actually the easier of the two. Okay. So wherever possible, we want to use the law of sines. Okay. So this one says that if you take the sine of any angle over the side across from it, it's equal to the sine of any other angle divided by the side that's across from it. Okay, so basically we can break this down into the sine of any angle divided by the side opposite is constant within a triangle. So we won't necessarily use all three of these ratios. You know, I might know one of the angles and the side across from it, and I might know another side, and I can use it to find the angle that's across from that side. So one thing that really helps students is to know when to use this one. Use this anytime you have a side and an angle pair. So use anytime you know an angle and side opposite pair. Okay, and I'll do an example to show you what I mean by that. Okay. Now, the second one, I always think of the Pythagorean theorem. You know, we've learned c squared equals a squared plus b squared. Well, it turns out that you can use that formula for any triangle if you add a little extra, and this is the added extra. Now, because we don't know, I mean, the Pythagorean theorem, we know that the longest side is called C. But for this one, you know, it's three sides, A, B, and C. It doesn't matter what side is A, what side is B, and what side is C. We can actually write this formula 3 times. You can use it any 3 ways. Okay. I like to look at the last one because it really helps me, because it's the closest to the Pythagorean theorem, to see the parts of it and help me to remember. Okay, so this is what helps me remember it. Basically, you start off with the Pythagorean theorem. C squared equals a squared plus b squared. And then you take minus 2 and then ab. And notice these are the same as the original. So these are the same as the other two that were in the formula. And then you do the cosine of the angle that's included angle. And one thing to notice is it starts with side C, it ends with side C. So if I'm ever writing this formula and I'm looking at it, and suppose I'm doing one or the other one, it's, you know, b squared equals, I know that it's going to be the other two sides squared added together, minus 2, and then you just repeat these again. And then it's the cosine of the angle that's between those two sides, which is going to be the same as the side you started with. So, okay. And you can write that pretty quick. This formula is harder to use. It involves more work, especially if you're solving for the cosine. You need to be very careful if you're solving for the angle using this formula, because there's a lot of order of operations mistakes you can make. Okay. So what I want to do is I just want to do a quick little example. So what I'm going to do is we'll call this example 1. So what I'll do is first I'll draw a triangle. What we're going to do for a lot of these is we're going to do something called solving the triangle. When you solve a triangle, you find all the non-given sides and all the non-given angles. So suppose I tell you this is 30 degrees and this is 10. Actually, I'll put it in red since it's one of the givens. And this is 10. And then I also give you that this is a 40-degree angle. Okay. So, and I want you to find all the other sides and all the other angles. Okay, now the other angle's easy. All the angles add up to be 180, so that one will be pretty quick. But to find a side, the first thing I notice is I have an angle side pair. I have an angle and I know the sides across from it, so I'm going to use law of sines because law of sines is a whole bunch easier. What the law of sines will allow me to do is to find either an angle across from a side or a side across from an angle. So since I know this angle, I can use it to find this side. So I'll call him x. And what the law of sines says is it says the sine of any angle divided by the side that's across from it is equal to the sine of any other angle divided by the side that's across from it. And then what I can do is I can solve this for x. Okay. So the easiest thing to do to solve this for x is, you can do the reciprocal of both sides. So 10 over the sine of 30 equals x over the sine of 40. And then you can multiply the sine of 40 on the other side. So 10 sine of 40 over the sine of 30 equals x. And then we can just put it in our calculator. So x is about, and I get about 12.9. And again, make sure you put units. There's no units, so I'll just put UN. Now what I could do is, and I'm not going to finish this one because I want to show you one of the law of cosines one, is what I can do is I can find this angle down here, and then I can do another law of sines to find this side right there, and I can solve the triangle. Then I have all three angles, all three sides, the triangle is solved. Okay. So let me do another one so you can see law of cosines. So I'll do the easier version. I won't do the one that is a little harder. We'll do that in class. So here's another triangle. Suppose I know that this is 30 degrees, and basically I'm going to give you side angle side. I know this is 10, and I know this is 15. So here's the problem with this one. I don't have an angle side pair. I've got 30 degrees, but I don't know the side across from it, so I can't use the law of sines. So I have to use law of cosines. Now what law of cosines will find is it will find the side across from the angle. So what I do is I'll call this x. So x squared equals 10 squared plus 15 squared minus 2, the 10 and 15 again, and then the cosine of the angle in between them. Now I have to remember that once I figure out what 10 squared plus 15 squared minus 2 times 10 times 15 cosine of 30, I do have to take the square root of it. So I'll put that in my calculator all in one step. So I get about 8.1. That's, yep, that is after I square rooted it. So x is about 8.1. Now once I do that, now I've got an angle side pair. Now I can go right back to law of sines. So law of sines can either find either of the angles. So I'll use the 10. Okay. So remember, the sine of the angle I know divided by the side that's across from it is equal to the sine of any other angle, we'll call him theta, divided by the side that's across from him. Now this one, you notice theta's in the sine, which means we're going to have to do an inverse sine to get to it. Okay, let's first solve for the sine of theta. So multiply the 10 to the other side. 10 sine of 30 divided by 8.1 equals the sine of theta. And then we can do the inverse sine. So theta is going to be the inverse sine of 10 sine of 30 divided by 8.1. Okay, so another calculator problem. I like to round the angles to the nearest degree and the sides to the nearest tenth. So I'll call this 38 degrees. And then if I take 180 and I subtract the 30 and subtract the 38, I get that this is 112 degrees. And then this thing is solved. One thing to double check is that the smallest angle should always be across from the smallest side, and the largest angle should always be across from the largest side. So if you take a look at your numbers, you can do a quick little check to make sure it at least sounds reasonable. So yeah, the 8.1 is across from the 30 and the 15 is across from the 112, so it makes sense. That's it for today. Thank you for watching. Have a great day.